In this talk, we'll talk about React Native. We'll try to understand what is React Native, how does it work, and why big companies such Facebook, Microsoft, Wix, Skyscanner so invested and adopt this technology. And I hope that after my talk, you will be able to develop a React mobile application with your knowledge in React, and you will really understand what is going on the device when your React code is executed, because it's kind of really easy to develop in React Native, but to develop good in React Native, you need to really understand what is going on under the hood. So let's start. My name is Lev. My background is Android development. I'm in Wix. I'm working at Wix for the last 2.5 years with React Native. If you are not familiar with Wix company, at Wix we are building a platform for managing businesses end-to-end, and starting from creating an awesome website. And with our mobile application, our users can manage their sites and their businesses on the go. And also, our users, even if they don't have a website, can create a digital place inside the application and create some kind of community around their business. So let's start. Before we dive into the React Native, let's do a quick recap about native mobile development. So in mobile, we have our prime frameworks, platforms are Android and Apple. iOS operation system and Android operation system was released around 2007, 2008 by Google and Apple. In Android, we are developing in Java and Kotlin. In iOS with Objective-C and Swift. And Android and iOS provide us an Android SDK and iOS SDK to communicate with the operation system and provide us some components that we can use. Also, both the operation system has some UX and UI guidelines, so there are a bit differences between the operation system. And the executable on Android, it's an APK, and on iOS, it's IPA file. And in the end, we can publish our executable, our application, in Android case, in the Google Play or some other stores, and in Apple, only at the App Store. So looking on the native world, a company that wants to create a good product targeting to the 3 major front-end frameworks need to maintain 3 different teams, such as in each team there are different expertise. We will have an Android team with Android developers that are expert in Java, Kotlin, Android SDK, Gradle, etc. iOS team with Objective-C experts and Swift, and the web team with experts like you in JavaScript, React, Angular. And there is 2 main problems in this model. First of all, although these 3 teams develop the same functionality, the same business logic, they cannot share the code between the teams, between the projects. And the second problem may be even bigger, we cannot share resources. We cannot take a good Android developer and give them to develop an iOS app. It's very rare that a good Android developer is also a good iOS expert. And what companies are doing, they have to compromise. So that was my phone. So they can compromise on 3 things. They can compromise on the money and time and really maintain 3 different teams. They can compromise on one of the platforms. I'm sure you're familiar with lots of startups that are doing first iOS app and then catch up with the Android app, or vice versa. Or then they can compromise on the quality of the application and develop with web-based solutions such as Ionic and Cordova that are trying to simulate the native use with JavaScript, with web component, and the result is not good. because they are not using the optimization that the native platforms providing them. So about 4 or 5 years ago, Facebook got this problem, and they understood that they cannot scale with native development. It's very hard for them to scale. Then they decided to develop the React Native framework. And about 4 years ago, Wix also joined the journey, just in the beginning of React Native. So let's understand what is React Native. To summarize React Native in one sentence, it's a framework that enables a developer to develop with JavaScript and React, targeting different platforms, but still using the native UI building blocks. Meaning we are still using the views from the Android SDK and the iOS SDK. For demonstration for this talk, we will use this simple app. It's application with one button, a like button. If we press on the like button, it will turn to dislike, and if we click again, it will be a like. So our project will look something like this. We will have a folder, Android folder, with all our Android native code, our Java code or Kotlin. We will have an iOS folder with all our iOS code. And we will have a source folder with our JavaScript code where we implement our business logic. Can you see the code? I can do nothing with this. Okay, so I will explain what is going on here. First of all, it's a React component. It's our app. First of all, we will import the components from React Native library. Here it's written React Native. We will import the image. We will import text. Touchable opacity is a different name for button. And view is a different name for div. Next, we will create our constructor and set our state for true, like. We will define our business logic. What will happen when we click on the button? We will change the state from like to dislike or vice versa. And we defined our render method that will return us a UI representation as we change the state. It needed to be clear that when we define in our JSX code image, eventually the class that will be responsible for rendering the image on the screen is the image view from the Android SDK and the UI image view from the iOS SDK. So let's see how this magic happens. To understand this, we need to dive into the React Native framework itself. And this is the React Native. We can split React Native into two main layers. First layer is implemented in native in Java for Android and in Objective-C for iOS. And it consists of something called native module. Native module, it's an implementation of a model that implements some functionality that requires a native API. Something from native, or some stuff that we just cannot implement in JavaScript because some limitation of JavaScript. Above this, we have a C++ glue layer that connects us to the JavaScript API layer that exposes an API to the React Native developer. Unfortunately, React Native do not cover all the native API. It's not covers, for example, notification functionality or camera operations. But React Native is extendable framework, and we can add native models implemented in native in Java and iOS, and add some JavaScript API and expose it to the React Native developer. Now we will understand what is going on through the build process and when we install the application. So in this case, we will go through the Android case because it's more interesting case. So in case of Android, our Java code and C++ code will be compiled as any regular native application. It will be compiled to binary files. And our JavaScript code will go through the process of bundling, like you're familiar from the web world. But In React Native, we are using Metro Bundler. It's equivalent to Webpack in web world. It's just more adjusted for React Native needs. And eventually we will take all our JavaScript code. It will be adjusted for the targeting JavaScript virtual machine that will execute the JavaScript code. And in most cases, the result will be huge JavaScript file. In some cases, we can split it to different files, small file. All this packed inside the APK. And when we install and run the application, the native code will be executed as any native application. And the JavaScript will be executed on the JavaScript virtual machine. In case of React Native, is the JavaScript Core. It's maybe you're familiar with the V8 from Chrome. JavaScript Core is the JavaScript virtual machine of Webpack of Safari. On iOS, it comes as out of the box from the operation system, and on Android, we need to bring it as a dependency of React Native. Between these two realms, we have a React Native bridge. It's actually a way to send messages between the native and the JavaScript, and from JavaScript to native, to invoke some method. And it's an asynchronic way of communication. And we're actually passing serialized JSONs between the two worlds. It's important to notice that in native, we have the main thread, which is responsible for rendering our UI on the screen, and for user interaction, for processing the user interaction. And we can create any other background threads as it's possible in native. JavaScript is a single-threaded framework, so it's executed in a single thread. That's all. So let's see how it works. When we launch our application, the launch starts at the native side that need to load and parse all the JavaScript bundle to the JavaScript virtual machine. Eventually, a render method will be invoked, and we will get the UI representation, and we will save it in the memory of in the runtime memory of JavaScript. It's actually the virtual DOM that you're familiar from React. After that, JavaScript will send this representation to the native realm through the bridge, and this is actually how the messages that are going through the bridge looks like. And on the native side, we have a library called Yoga that is responsible for translating JavaScript JSX instructions that are written with Flexbox to the native UI instruction, to native views. And it's responsible to measure the screen and put the views on the right spot on the screen. It's an open source library by Facebook as well. And eventually we will render our virtual DOM on the screen. As user clicks the button, the touch event happens on the native side, and we will send this event to the JavaScript because we need to know what to do with this click. Our business logic is on the JavaScript side. On the JavaScript side, on-press button will be invoked. We will change the state, and again, a render method will be invoked and will return us a new representation, a new virtual DOM. And here, familiar reconciliation process will be done on the two virtual DOM trees, and we will find the diff that will be sent back to the native, and we will update the native side. So this is how React Native works, and it looks awesome, and it's kind of work. But everything comes with a cost. And in some cases, there are some problems. And I want to introduce you to some problems that we have currently with the React Native architecture. So first of all, the bridge, the fact that we have a single bridge and the JavaScript is single-threaded, in some cases, the bridge and the JavaScript thread might be busy. For example, this is the messages that are passing on single click. Although they are batched but still it's a lot of string to serialize, deserialize, and move between the threads. Let's look on a simple example, familiar to all of you from your phones, a dialer. Let's try to implement a simple dialer, and we want to add dash after the fourth digit, after 6. Like after the user click on the fourth digit, we want to add a dash before the fourth digit. So in case of, if I would implement it on Android, this will be my code that validates if I have 4 digits, add dash in the text. And this code will be executed on the main thread before we render the digit 6 on the screen. It will be blocking. In the world of React Native, because we're working on the two realms, the JavaScript and the native, we will render the 6 on the native side and then validate this text on the JavaScript side. And the result, in case of busy JavaScript thread and busy React Native bridge, this might be the result. Eventually, we are getting the right result, but the way to this result might be problematic. Let's understand why it happens. So when we click on 0, the first digit, we are sending this information to the JavaScript. We are setting the state text 0 and returning to the native. The same with the second digit, the same with the third. When we click on the fourth digit, we are sending to JavaScript the 4 digits, then we decide to add a dash, and then only then we return to the main thread to update the text. So the bridge has several downsides. First of all, in some cases, we want to be able to communicate between the native and JavaScript in a synchronous way, such in this example. Second, the serialization of JavaScript and deserialization is very heavy and expensive operations. And the third one is jumps between the threads that we don't actually need. So React Native team decided to write the new architecture and to overcome these issues. And now we will go over the new architecture that is currently developed, but it's already in the master of React Native, and it's half working. It's toggled off with a feature toggle. So to understand the new architecture, we need to understand the runtime environments that we have on our phone when we are executing React Native application. We have the Android runtime environment, which is the equivalent to like a JVM, Java Virtual Machine. It's a virtual machine that executes Java code, Android code. And as any JVM, it has JNI, Java Native Interface, which enables us to communicate from Java to the host machine, to the C++ code of the device. The same thing we have on the JavaScript side. We have the JavaScript virtual machine, and the JavaScript virtual machine has the JS context, which enables us to communicate between the outer C++ code and the JavaScript. We can register some methods on the global of the JavaScript and invoke them from the C++, or we can register on the C++ side some methods on the JavaScript context and invoke them from JavaScript. So actually, we don't need a bridge. We have straight communication between JavaScript and Java. So in the new architecture, Facebook presented something called GSI, JavaScript Interface. And this is actually a new way of communication between the JavaScript and Java. So it will work like this. We will have something called host objects, and it's a C++ object that will enable us to communicate between the JavaScript and the native. They will expose the Java methods to the JavaScript vault. And the JavaScript code will hold a reference to these host objects. And we will be able to invoke these methods from JavaScript to native and vice versa, synchronously or asynchronously. If we want, for example, to invoke method from JavaScript to native asynchronously, we just call some method, open a new thread on native, and go back to JavaScript. This is asynchronous. So let's do a quick demonstration. Let's say we have a Java method do something in native that will print to the log doing something in native. On the JavaScript code, we want to be able to execute sample model, do something in native, and eventually we want this code to be executed. So for this, we will need a C++ code that will bind these two stuff. In this code, we are setting on our global a host object. We'll create a host object and set it as property on the global of the JavaScript. And we will be able to invoke from JavaScript through the JS context to through the GNI to the Java. This code is where the React Native developer is not supposed to implement this C++ code. And it's kind of generic code. And currently, React Native team working on implementation of auto-generating this code by defining an interface in JavaScript. So this code will be generated in build time, and then we'll be able to invoke this code. So what we get from the GSI? So first of all, we don't have now JSON serialization and deserialization when we communicate between the native and JavaScript. Second, we can execute JavaScript code on the main thread. Third, we are reducing the jumps between the threads. And it's now very easy to create a cross-platform native model in C++. For example, if we want to take some C++ library like FFmpeg and to integrate it to React Native, it's very easy now. And maybe one of the important things is that current implementation of React Native is very coupled with the JavaScript Core engine. And the JavaScript Core engine is not the best engine for example, for Android operation system. And the new JavaScript interface, the GSI, is implemented in such way that we are decoupled from the engine that we are executing the JavaScript code on it. It's something like this. So now we have async or sync communication, and we have the GSI abstraction layer, and we are able to replace the JavaScript core with, let's say, V8 or Hermes. If you know, last week Facebook released a new JavaScript engine called Hermes that is adjusted for React Native and for mobile in general. Let's see what are the advantages and disadvantages of React Native. So I want to start from the fact that our code, our business logic is implemented in JavaScript. It's enabled us to do continuous deployment on mobile, something that is not possible today, because we need to go through the App Store and through the Google Play. With JavaScript, we can send directly the JavaScript bundle to our users, and we can update the code like it is done in web world or in server. It's a very cool thing. And there is a library called Code Push, with which it's a Microsoft library that all these capabilities comes out of the box for you. So the advantages are that we're able to share code between Android and iOS, and sometimes with web. We can share development power, we can share resources. It's really, really easy to take a good React developer and convert him to be a mobile developer. We reduced the cycles of development, because in native we need to compile the code and each iteration we need to wait until the compilation finish. And in React Native, we can use hot reload, live reload. We can use JS6, which is very convenient for any developer to define the UI. And instant distribution, as we said before. And maybe the most important thing is that our teams are now not platform-aware team, but they are product-oriented teams. Meaning we don't have an Android team and iOS team, we have a mobile team. And it's very, very important when we're working in scale. But as I said, it's all come with a cost, and there are some challenges. First of all, performance, as we said before, we still have some architecture bottlenecks that are currently in a process of solving, but who knows? We still have problems with startup time. It's also kind of already resolved, but not perfect. For example, think of a good application like WhatsApp, Telegram. It opens immediate. In React Native world, we need to load the JavaScript to the JavaScript engine, and it takes time. For example, in our case at Wix, our JavaScript bundle is around 20-25 megabytes, and it takes time to load all this JavaScript code. It's a new framework. We're only in version 0.60, and we have often upgrades, and sometimes these upgrades have breaking changes, and it's annoying. And one of the biggest challenges is there are not enough development experience, meaning there are not enough profiling tools, there are not enough crashing tools, monitoring tools that in native world we already have for a long, long time. And we need to develop them ourselves. And as I said in the beginning, it's incomplete. We have a lot of functionality that is not implemented out of the box in React Native, and we need to implement this functionality ourselves or be dependent on some open source, which is known that dependencies are not always good. For a good example for some tool that we developed at Wix and of course released open source is our UI automation testing tool called Detox, which is running on our CI and execute end-to-end tests on our application. And we have a lot of tools and infrastructure libraries. Actually, we're trying to open source any library that has no Wix-related business logic. Anything that is infrastructure is released open source. And to recap all this, as time goes, more and more serious and big projects adopting React Native. And this project has higher performance requirement and more complex feature, and they challenge the framework. And this is actually what is moving the framework, the React Native team, the community, to improve the framework and become more stable. And currently at Wix, we're 80 developers. We are about 40% of us are with native background, Android or iOS, because we still need to implement native modules and we still need to implement infrastructure and tooling. As you can see here, we have 3 JavaScript and 2 native. We can share about 80% of our code between Android and iOS, and we share some functionality also with our web teams, not the UI layer, but for example some SDK that is written in web. We are sharing resources with the web team. For example, we can take a web developer that are working on some product and already familiar with the product. After a quick onboarding, he will be able to do the same product on the mobile. And we are one of the biggest React Native projects in the world. 80 developers for a single application, it's a huge project. That's all, thanks. And we always looking for good new Java developer that will join our teams. So feel free to talk to me and catch me here. Questions? We have time for questions? Yeah. No? Okay, questions there. There is question there? Yeah. One question is okay? One question.
Thank you for your ideas. My question is that these days come more of my research is Flutter.
Uh-huh.
What do you think about their future? If Flutter will come React Native or not?
Okay. So there is always question about Flutter. Flutter seems very promising. It's a great project. They have great documentation they just released. Also, the new operation system, Fuchsia, that's supposed kind of replace Android, is also very coupled with Flutter. But we don't really know the real problems of Flutter because there is no really big production project in Flutter. So it's unclear. If I had a startup and I need to bet on some framework, it will be a big risk to choose Flutter now. Because the problems of Flutter are still unknown. The same was for React Native 3 years ago. It looks promising, looks amazing, but as our project become more complex and bigger, we found some problems in the performance. So now they changing the infrastructure. I think there is a place in the future both for Flutter and for React Native. Flutter is not using the native views. Flutter is like a gaming engine. It simulates on the GPU native views. The performance is amazing, but you don't have all the native views. The app will look the same. So.
Basically, you can provide like a complete development cycle without like all three groups of developers, Android and even now, right?
I cannot or can?
Yes, you cannot because of those features which you can actually
In
implement in React Native.
in big project, I cannot. In small project, I can rely on open source and stuff that someone will implement for me.
Generally, big projects, one way or another, you have to combine all of them.
Yeah, yeah. It's the amount of people that you need. Native and the development experience in native is better. Like Android Studio is better. The profiling tools are better, and the debugging and the crashing, these stuff are much more developed than in JavaScript world. But for me as a developer, I don't really care what language to write, but it was very interesting to understand how JavaScript works and how it combines with mobile. Android developer. Java, it was before Kotlin. That's all?
Probably no questions.
There is more questions?